Bismillahirrahmanirrahim. Now today we are going to start 12.2, the chain rule, and for this chain rule we will use this d by dx will be obtained through dy by du and du by dx. So for exercise 12.2, this is additional mathematics course for IGCSE and O level. And, this chain rule will be used here for exercise 12.2. So we'll use a differentiate with respect to x for this higher orders. For this higher order we have to find solve it and then take the differentiate. That's a difficult one, so we can suppose this bracket value to some intermediate variables, and by using chain rules we can differentiate this by dx as discussed. So let's solve 12.2. There are a number of problems from A to L, and we will solve differentiate with respect to x. Similarly for question number 2 and 3. So now start size 12.2. So this is x plus 2. We have to differentiate with respect to x. So let's suppose this y as a y, and here this is x plus 2 is taken considered as u. So this y becomes u power 9, and this y can be differentiated with respect to u. So this becomes 9u power 8. So and this u can be also be differentiated as with respect to x. So this du by dx is equal to 1. So by applying a chain rule, dy by dx is equal to du by dy by du and du by dx. This du cancel out, and this becomes dy by dx. So by in place of dy by du we will use this, so 9u power 8. And for this du by dx, here we have 1, so we have this. So this dy by dx becomes 9u power 8 into 1, so 9u power 8. In place of u we will replace this x plus. So in place of u we'll use x plus 2 power 8. So this is dy by dx. Similarly for other ones, let's move to E. Here we have y is equal to 2x plus 1 power 6 divided by 6. Here we have considered u as this one, so this y becomes this. So this u is 2x plus 1, so du by dx is equal to 2. So in place of dy by dy by du we have this. By using chain rule, dy by dx, dy by du, du by dx. In place of dy by du we write down. In place of du by dx we have 2, so we write down here. Solve, and we have obtained 4u power 5 for dy by dx. In place of u we'll place the value u. So this is 2x plus 1 in place of this, so it becomes this. So let's move to last one. This. Okay, this y is equal to this x square minus 3x power 5. So let's assume u this one. So du by dx is equal to this one. So u is u power 5. So differentiate 5u power 4. So dy by dx by using chain rule becomes this. In place of u we'll place this u value, so it becomes this. So for L, x square plus 2 upon u, this is u. So differentiate with respect to x becomes this. This is u power 4, so dy by du this, and in place of this we will write down. In place of u we will write down the value of x, so it becomes this. So this is we can leave it here or here. it's all okay. Differentiate with respect to x, so y is equal to 1 over x plus u. This is u, so u dy by du and du by dx, this is 1. So using chain rule, you can this in place of u place this value. Similarly for this one, for this one, this is u, so du by dx this. So applying chain rule, this you can use this. In place of u, put the value of u here, and this case is so it's easy. So similarly for this last one, this y is equal to 2 upon 5x plus 1 power 3. This is u. So y dy by du and du by dx by chain rule. Simply say this. So this is easy. Now differentiate with respect to x. For this one, u, so this becomes u, this du by dx, so this, so dy by dx, this. For this one, d, u, this du by dx, u is this, so dy by du, this is this, and du by dx is this. So in place of this, place the value of u here, and then similarly for last this one, g, problem number g part, this y is equal to 1 over this, u is this, and du by dx is, place this, and dy by du and du by dx, chain rule, and then place the values and eventually get that. And this is so difficult, h1 3 power cube, so it becomes this. So we'll take the differential dy by du and the du by dx, and then eventually comes to this. Problem number 4, we have y is equal to 2x minus 5 power 4. We have to find the gradient dy by dx at this point. So use this. So dy by dx, we have obtained this value, and we have to find the gradient at this point. So we will substitute the value at this. We will get this value 8. So that's 5. X y is equal to this. Curve crosses the x-axis. Let's read the problems. Number 5. So find the gradient of this at the point where the curve crosses the y-axis. When curve crosses the y-axis, at that point the x becomes the curve crosses the y-axis. When y-axis crosses means x is 0. So for 5, problem number 5, this x is 0. So for x is 0, the value is obtained. The value of y will be obtained. So for problem number 5 is the gradient, and we have to find the gradient. So actually this value. So this x is equal to 0, so we have to find the gradient first, and by chain rule we have obtained this. And this, since this is crossing y-axis, so x is 0, so in this, at this gradient we will apply this and get the value of this. So this was our required value. So let's find this for the coordinate of the point. Question number 7, for the find the coordinate of the point of the curve where the gradient is 0. So dy by dx is equal to, we have to find the coordinate where this curve and this gradient satisfy. So this is question number 7. So we have this y is this, so this is assumed as a u, so du by dx. By applying chain rule, we have obtained this dy by dx. At this value, the gradient is 0 as given in the problem. So x becomes 3, so y is equal to 3, 2. So at this value, coordinates is obtained as x is equal to 3 and y is equal to 2. This was the required value. Similarly, for problem number 8, we have a curve this and the point passing through this point and had a gradient this at this point. At this point the gradient is this, and passing through this point we have to find the value of a and b. So we will solve question number 8. So we have this curve passing through this point, and the gradient at this point is minus 3 by 2. It is given, and we have to find the value a and b. So this we will find the differential or gradient first by using a chain rule. So this is, so we have this dy dx is equal to this one, and at this value we have 1/4, so we'll pass through this 1/4. So by this substitution we have this. So this is one of the equation that has obtained, and the second one is by substituting the value 1/4 here in this curve, placing 1 here, and y is equal to 4. So as a result of that we have this equation. So from this equation, on simplification, ab plus 1 is 4, a is equal to 4 into under root b plus 1. See, this a is this one, so this, in place of this a we can place this value. So by placing it appropriately we have obtained this. On simplification, this, so eventually the b has obtained 3, and this v value is placed here to get the value of a. So we have obtained the value of a, and this was our required values, so we have obtained it. And in the next section we will cover 12.3.